Hey, what's up, guys? Welcome back to the channel. It's been long, honestly, a long break, so you guys have my sincere apologies for that. Today's video was supposed to be aired somewhere between 7th to 14th January, but I got hit by some stuff and I had to get that covered. However, as for today's video, when I contacted a friend of mine, Hasnan Nazir, according to him, history of computers, it is a very vague chapter. Different sources have different views and opinions, and when I dived into it myself, I couldn't disagree with him. And yeah, by the way, Hasnan is an amazing web developer. You guys can check him out. Link to his Facebook will be down in the description. So, history of computation has its roots laid down in the prehistory, like the Ishango bone, which date back to 18,000 BC to 20,000 BC. A bone tool, possibly from a baboon, is believed to be a mathematical object with a sharp piece of quartz fixed at one end. It is thought to be a tally stick as it has marks carved on it in different columns running its length, referred as tally marks, though it's uncertain if those marks were for counting purpose or for better grip to handle it. Similarly, the Chinese Suanpan or the Abacus was developed from devices used in Babylonia dating back to 2500 BC, a calculating tool used centuries before the adoption of Hindu-Arabic numeral system. And the Antikythera mechanism, discovered in 1901, is believed to be the first analog computer designed to calculate astronomical positions. It was discovered from Antikythera wreck off the Greek island of Antikythera, dating back to 100 BC. Concept of first programmable computer was laid by Charles Babbage in 19th century. After his work on the difference engine in 1822, the difference engine 0, an automatic mechanical computer, he further worked on the analytical engine, a mechanical general-purpose computer in 1837. Though it remained incomplete, a complete version of the analytical engine, also referred as the mill, was made by Henry Babbage, Charles Babbage's son, in 1888. During the first half of 20th century, many scientific computing needs were met by increasingly sophisticated analog computers. The type predicting machine was the first modern analog computer built by Sir William Thomson, also known as Lord Kelvin, in 1872. It was set up to predict ebb and flow of sea tides at irregular variations. In 1876, the differential analyzer, a mechanical analog computer, was designed by James Thomson to solve differential equations by integration using wheel and disk mechanism. The Torpedo data computer, developed in 1938 by the US Navy, was the first electromechanical computer, small enough to be used aboard. It used trigonometric functions to fire a torpedo and a moving target. Early digital computers were electromechanical, using electric switches to drive mechanical relays to perform calculations. The Z2, created by Konard Zuse in 1939, is an earliest electromechanical relay computer. In 1941, the Z2 was followed by Z3, the world's first electromechanically programmable, fully automatic digital computer. Sooner, electronic circuits replaced mechanical and electromechanical equivalents, and at the same time, digital calculations replaced analog calculations. In 1942, John Atanasoff and Clifford E. Berry developed the Atanasoff-Berry computer, or the ABC, at Iowa State University in the US. It was the first automatic electronic digital computer. During World War II, Max Newman and his colleagues built the Colossus in 1943 to crack sophisticated German Lorenz SZ40 and 42. It was the world's first electronic digital programmable computer. The first working prototype, Colossus Mark I, was used at Bletchley Park in early 1944, and the improved version, Colossus Mark II, in June 1944. An amazing fact is that the existence of Colossus machines was kept secret until 1970, and all the plans to rebuild them were destroyed in order to maintain the secrecy of the project. The Electronic Numeral Integrator and Computer, or simply called the ENIAC, the first electronic general-purpose computer designed by the US Army in 1945 and put to practical work on December 10, 1945. It was primarily used at US Army's Ballistic Research Lab. The principle of modern computer was proposed by Alan Matheson Turing in 1936 in his seminal paper on computable numbers. He proposed the idea of universal computing machine, which is now referred as universal Turing machine, where all the functions for computing are stored in memory. Early computers had fixed programs. It had to be rewired and restructured in order to change its function. After Alan Turing's concept of stored program, it changed. The Manchester Baby was world's first electronic stored program computer built at Victoria University of Manchester by Frederick C. Williams, Tom Kilburn, and Geoff Tootle, and ran its first program on June 21, 1948. As soon as Manchester Baby had shown its feasibility, despite the fact that its design was considered as primitive, it had all the essentials for a modern-day computer. A project was initiated to develop a more usable computer, and Manchester Mark I was developed and was operational by April 1949. The Manchester Mark I quickly became a prototype for the Ferranti Mark I, world's first commercially available general-purpose computer built by Ferranti in February 1951. And in the same year, it was followed by the Leo I, which was created by J. Lyons and Company, and it ran its first business application in June 1951. In 1953, the very first transistor-based computer was designed and built at the University of Manchester by Tom Kilburn and his team. Followed by transistors, Muhammad Ahmadullah and Dawon King invented the metal oxide silicon field effect transistor, or MOSFET, at Bell Labs in 1959, which were more compact and could be mass-produced for a wide range of uses. It led to the revolution of microcomputers and became the driving force behind computer evolution. The next advancement in computing came with the advent of integrated circuits, or IC. The first working IC was invented by Jack Kilby in July 1958. Half a year later, Noyce came up with his own idea of monolithic IC chip, which resolved many drawbacks of Kilby's IC. Modern monolithic ICs are predominantly MOS IC, built from MOSFETs. The development in MOS IC led to the invention of microprocessor. Then came the system on chip, or the SoCs, a complete computer on a microchip equal to the size of a coin, which may or may not have RAM or a flash memory. Furtherwards, portables came into business. In 1975, IBM introduced a portable computer, the IBM 5100. After the IBM, Osborne 1 was released on April 3, 1981, which was a successful portable mini-computer. It further continued by Compaq releasing their portable computer in 1983, namely the Compaq Portable. All these amazing creations have led their way into today's world. The smartphones and tablets that we use today run on a variety of operating systems and have become the dominant computing device on the market, are also powered by SoCs. And with all that being said, thank you so much for watching. My name's Haris. This is FantasTECH. Catch you in the next one. Peace.